Good evening. I hope everyone's as tired as I am. We're running a little late, but it's good to be here for such a massive audience. My name's Neil Brooker. I'm a technical specialist manager for Autodesk. I manage a team in the Middle East, the Mediterranean area, including Turkey and Russia. I live in Dubai. See? Tan. So I come here quite a lot, so it's a pleasure to be here. I'm going to be talking about utilities, and specifically around BIM for utilities and what Autodesk has to offer in terms of creation and management of utility networks and design. So first of all, utility infrastructure is quite a dry subject, but utterly essential. There are many challenges in the utility industry. There's a few of them listed here. The first one is aging infrastructure, and being in a city like Istanbul, I think you can understand the implications of this. I come originally from England, and I know that in London there are some water pipes and sewage pipes that are more than 150 years old. And I'm pretty much sure that in Istanbul the same thing will apply. So we've got a lot of old infrastructure, old utilities that we basically sometimes don't even know where they are. And they can explode and burst, and we have all sorts of problems. We also have a drive towards smart grids. Smart grids in the electrical sense are driving volumes of information and data, and also technology innovation. For those of you who don't know what a smart grid is, it's a kind of, in simple terms, a self-regulating energy supply that understands where it needs to push extra energy, where it can cut back in the circuit and so forth. Another issue that we face is urbanization. By the year 2050, when I probably won't be around, 70 to 80% of the world's population will live in cities, like Istanbul. Not all in Istanbul, that would be a traffic nightmare, but the fact is that more and more people are living in cities, and of course we can't put them all into existing cities. People are building new cities. Look at China, for example. They're building something like 50 new cities in the next 25 years. The UAE, where I live, are building new cities from scratch. And of course, these all need utilities. There's also changing in the workforce. Some of the old practices are beginning to disappear. There's more need to be accountable and transparent in terms of the assets that are being created and managed. The tools that we use are modernizing, and Autodesk is obviously a part of the tool set that people use. And, you know, a lot of the old practices are going out. The traditions of working in silos and engineers locking up information and knowledge to themselves and locking it in kind of dumb CAD files or in lockers is going away. So we need more intelligent models that are shareable and transparent. So there are a lot of business challenges, a lot of opportunity as well in utilities. The utility life cycle is not much different from any other construction or engineering life cycle. You've probably seen this sort of diagram before pertaining to architecture, for example. It's the same in utilities. We essentially have planning, designing, building and managing phases of large utility projects. And Autodesk does have tools to help in all of these phases. So I'll come on to this later, but products like Map 3D with industry models and Autodesk utility design are essential to our strategy. And I'll come back to that in a few minutes. So what do we mean by utilities? No big surprises here. Electricity, gas, water, sewage, and telecommunications. All of these are well known as our utility industries. What is BIM? So what is BIM for utilities? I think Peter was talking about BIM earlier, probably gave a different explanation. To me, BIM is the use of an intelligent model. It's not a software, it's not a person, it's not a shop in downtown Turkey, Istanbul, that Thomas found yesterday. It's the use of an intelligent model through all of those phases of a project or an asset management system. And why do we need BIM? You don't really have to talk about this, you can just look at the pictures. A lot of owner-operators don't actually know what they have, they don't know where it is, they can't risk assess, and they could be liable to legal action, electrocution, that kind of thing, because of this. And you can see some of these pictures here, how on earth anybody could actually build that there, I have no idea, but they do. It's a strange one. It's like having lampposts in the middle of a cycle track. So there's a need to have a consistent, intelligent model that not only designs but also tracks your assets and your maintenance. Let's have a quick look at this video just to show you what we can actually offer at Autodesk at the moment. If there's some sound on this, that would be good. Okay, so I like that car at the end. I wouldn't mind that one. Maybe in a different colour. Some dramatic music to show pipes and wires. But the thing about that video was, it just underlines the amount of things that you have to consider when you're managing utilities. And you probably saw some examples there, not just of substation design, but GIS, structural analysis, civil engineering, as well as actually, asset management and planning. So a lot of things go into the detail about the BIM model for utilities. Where do they come from? Well, currently at Autodesk we have Infrastructure Design Suite, which has a lot of the components that you need to plan and implement a proper BIM for utilities project. These are just a few of them. Some of them you may know, some of them may be new to you. I'm just going to pick out a couple that I'm going to be talking about briefly here. So Map 3D, Navisworks, Utility Design, and Infraworks. I'm going to just cover off for you to show exactly how they fit into the life cycle of a utilities project. Let's start with conceptual design. Conceptual design is increasingly important to all sorts of construction projects and utility projects as well, because it allows you to rapidly conceptualize and design in context what your plans will be. And not only that, but take the data forward into the detailed design phase of your project. The great thing about conceptual design now is that anyone can be a visualization expert without even trying. The softwares these days, and I'll talk about one in particular, allow you to really analyze your ideas rather than have to spend hours trying to get that perfect angle or that perfect snapshot. So why do we need it? Well, I've just said, you can visualize projects rapidly, you can compare different alternatives rapidly, you can explain proposed solutions to the people that care, or the people that have the purse strings, the money. And you can generate preliminary estimates to back up your choices of your design. So I'm talking in particular about Infraworks. We've already had a couple of Infraworks snippets or teasers, and I'll be giving an Infraworks session in an hour or so, probably around midnight. And Infraworks is a relatively new tool. It's been around for a couple of releases now. But it's a design tool that lets you create, visualize, analyze, and evaluate your ideas. And it's really extremely useful in any construction project, not alone utilities. Here's an example of how Infraworks can help you visualize what exists. So this is in Edmonton, in Canada. And this is an amalgamation of GIS data and engineering information that in this case is going to help them develop a new metro system and associated utilities in the city of Edmonton. You can see here that we're also using point cloud technology now as well. And the point is here, it's all being done in context. So I can now design and create proposals in context, in the proper geographic location where my project is going to exist. And you can do this rapidly. This may have taken 10, 15 years ago, this may have taken a month, maybe even more, if you even knew the software. Today you can generate a model like that in a matter of hours, which leaves you time to actually concentrate on the important things, like the detailed design, the cost of your project, etc. Here's another example of Infraworks where you are visualizing. Let me just start it off. There we go. Visualizing your project in context, but you can actually now see the underground assets. So these are all underground. You can look through the terrain in Infraworks. You can assess where your assets are. They all have precise geographic locations. So this is real world. And you can have as many alternatives of this as you like. You can see there you also have color-coded pipes and cables to tell you what is water, what is gas, what is electric, and so forth. Very visually rich, very instantly giving you the information that you need in real-world context. Here's an example of using Infraworks in a large utilities project. It's actually more than a utilities project. It's a hydropower generator in Kunming in China. It's definitely in China, Peter. He said he thought it was. But I have a video. You didn't. So here's a video of a real-world example of using Infraworks on a massive scale. So this is a huge hydroelectric project in Kunming. And this combines not just utilities and geography, but also combines component parts from software such as Inventor, structural detailing. All of those component softwares that Autodesk provides have all come together to provide this particular project with the power to conceptually visualize the dream, if you like, the end product, before they even pick up a Civil 3D cursor or an AutoCAD cursor or a Revit cursor to do the detailed design. There's also new technologies, of course, associated with conceptual design. So this is an example of augmented reality, again on a handheld device, the one beginning with I. And you can see that not only can you use the camera to look at the real world, but you can place your Infraworks model into that real world scene in the precise location that you're at, because it's all geographically located. So you take your intelligent conceptual model into the field and you can view your assets underground, overground. If it's a building, you can put it in the field that you're going to destroy or rip up and to put the building in. So very powerful new technologies coming on board. Taking that even further, oh sorry, that's the next presentation. Taking that further, you can actually use Oculus glasses now to actually immerse yourself into your model. So it's almost as if you're inside your model, so you can walk around, move your head up and down, and you can see your conceptual design. You can do that on a laptop, or you can do it in a more expensive cave environment. Second bit of technology I'd like to talk about, actually I'm going to let somebody else talk about it, is Autodesk Utility Design. Has anyone heard of this or seen it in action? Anyone in the room? Oh, you're probably going to watch the same video again. That's lucky you know. Yeah, so, okay, that's good. So, utility design is a product that we have that is based on AutoCAD. It's actually based on AutoCAD map, to be honest. And it allows you to create utility projects in intelligent 3D models. So these models are not just arcs, lines, points, circles. They're real-world features that all have information behind them. They have relationships to each other, and you can create standards and rules about those features. So when you're drafting a network, it will know, the model will know that it cannot connect a 120-volt cable to a, I'm making it up now, a 60-volt transformer, for example. That sort of thing. That actually sounded quite reasonable. But that sort of intelligence you can't get in traditional 2D CAD. A word of warning about utility design. At the moment, it is only actually functioning for electric networks. Others will come on stream later, so things like water management, wastewater. But at the moment, it's just for electric networks. It also allows you to do a lot of reporting and analysis on your design. Okay, I'll skip that. So, like I said, I'm going to play a video about utility design to explain exactly what it is. And this one has got sound on it.
Analyze and right-size network assets, determine materials and cost estimates, and automate the delivery of more consistent and coordinated documentation and model information. Let's take a look. Using AutoCAD utility design, you can improve layout productivity, rules-driven standards, and easy-to-use design templates and workflows. You can also drive greater consistency across design teams by building standards and intelligence into the design process. With AutoCAD utility design, more accurately size and place assets using integrated engineering analysis, including automatic guiding, voltage drop, and clearance check to help optimize designs and enhance network reliability. During validation, as the design model is changed, the related documentation can be automatically updated. Using AutoCAD utility design can help you deliver consistent, higher quality documentation and cost estimates. All documentation updates change the design model. The solution enables you to integrate with third-party work management, inventory, and asset systems so you can better manage work orders and the design-to-build process. Users can generate and deliver construction documentation, including materials and labor cost estimates, in a single package. Finally, you can share intelligent industry models with GIS and other operational systems, such as enterprise asset management, to help minimize as-built backlogs and better respond to information requests.
Okay, so just a quick video there on some of the major features of utility design. That video actually goes on for ages, so I didn't want didn't want to do that to you. It's the important things about that were the data model, the intelligent features, the powerful reporting engine, all the things that are actually, you know, a generation on from traditional 2D CAD, where these are real-world features that react with each other and have their place in a business model. I'll come back to data models a little bit later. I'm just going to talk about Navisworks. So Navisworks is another part of BIM for utilities that you can utilize today. So Navisworks is really a data collation tool for engineering and construction information. It allows you to bring together many different sources of information into one place. And it's not just data, but it's attributes and so forth. It could be Autodesk formats, it could be other people's formats. It brings all of this in together into one project-focused model. I'm just going to skip those. Here's an example of a Navisworks model. This is a converter station. Again, I think it's in China. The Chinese are doing great things. And this is a combination of data from Civil 3D, from Revit, Revit Structure, Revit Architecture, Inventor, probably maybe some MicroStation in there as well, DG and so forth. One of the most powerful things about this, though, the Navisworks product, is you might be thinking to yourself, well, I just saw Infraworks and it looks pretty similar. But actually, Navisworks allows you to do a little bit more than just conceptually design. For example, it will allow you to view all the intelligent information behind your assets. It will also allow you to create timelining construction sequencing. So when you have a construction project, whether it's a fiber optic network or a new highway, you can schedule and sequence the steps that you will need to take to create that project within Navisworks. And you can attach cost estimates, of course, to that. It allows you to really validate a project that may be undertaken by a variety of contractors and subcontractors. If they're all working to the same BIM specifications, the same model specifications and schedules, technology like Navisworks can help you bring that all together and to actually analyze the efficiency of your project. So you can see here that we've brought in, it's almost like a Gantt chart, for those of you who like Gantt charts. We brought in some scheduling information, and we can sequence that information to actually visually compare what is being produced to what our original plans were. So you can see again, it's a little substation, and we're creating all of the assets in there in a particular order at particular dates. So that's one part of Navisworks that could be of benefit to a BIM for utilities project. Another part, and I'm just going to squidge this forward a bit, is clash detection, or what's the other word for clash detection? Interference, that's it, thank you. Or interference control. This is especially important for utilities because, you know, very often assets underground are hidden. They are always hidden. They also may be put there by different companies, electric, water, whatever. And you may find someone digging up a patch of dirt and trying to put in something where there already exists a gas main, for example. So planning precisely and being able to actually clash against different models is extremely important. So if I get some information from one subcontractor about the gas mains and get another bit of information about the water mains from someone else, I can put them together and see where they're actually going to cross each other and interfere with each other. So two very important aspects of Navisworks that help benefit utility management and utility construction projects. Everyone heard of Navisworks? Couple? Do you use it? No? Okay. Are you planning to use it or going to try? Or maybe. Okay. Good. It's a very, very powerful tool. It's really on the project construction phase that it really comes into itself, whereas Infraworks is more on the preliminary planning phase. This is in the construction phase. Okay. Finally, today I'm going to talk about another part of the BIM story for utilities, and that's Map 3D. And this essentially comes into its own in the planning and maintenance or management phase of a project. Map 3D is AutoCAD with geospatial bells and whistles technology embedded in it. So it's really our geospatial engine. For those of you who saw Peter's presentation, he was talking about Civil 3D, how that actually has Map 3D in it to give us the geospatial technology that we often need in projects. One of the great strengths of Map 3D is data connectivity. There is a lot of GIS data in the world. Some of it is free, some of it is very expensive, but there's a lot of it. It's held in all different sorts of formats. GIS formats, drawing file formats, DWN formats, you name it, database formats such as Oracle and so forth. There's a lot of it there. And it's really useful, of course, in any BIM project. What MAP enables you to do is to connect to all that information in an intelligent way to help you plan, to begin with, your project. So if you can imagine using an AutoCAD environment in 2D with all that data connectivity for environmental analysis, social analysis, design from Civil 3D, from AutoCAD and so on, in conjunction with a rapid visualization tool such as Infraworks, you have a very, very powerful planning tool just with those two products. What Map 3D also does is allow you to manage your project once you've finished it. So once you've created your utility project, your pipes, your electric network, whatever it is, you can intelligently manage and maintain your assets and your data and analyze that information in Map 3D. And not a lot of people actually know that this capability exists, which is why I'm going to tell you about it. Because in Map 3D, we have these things called data models. I talked about data models in utility design. This is pretty much the same thing. It's structured data that you create as a standard for your project. You can have enterprise or standalone data models. What does that mean? Enterprise data models reside in a massive database that hundreds of people can access at the same time. So they see exactly the same data at the same time with exactly the same colors, line widths, attributes, all that sort of stuff. They can also edit the data at the same time with rules. So again, the rules being a gas pipe cannot connect to a water pipe. They can edit simultaneously because they have rules around role management, who can edit what, how long they can edit it for, all that sort of stuff. It's extremely powerful. You can customize it as well. I'll skip that. You can also analyze your data. So, for example, you may want to know about your network connectivity on your water network. Which pipe connects to which valve? How many pipes are actually connected before we get to the water pumping station? That kind of question you can answer in Map 3D data models because it has a geographic engine, it has rules, and it has information about every single feature. What we do in Map 3D is supply you with empty containers of features for these particular utility industries. Not that one, that's not utility. So gas, electric, wastewater, and water. So what you get in Map 3D is a huge schema that has features like pipe, valve, conduit, transformer, primary cable, secondary cable, and so forth. And you can put your GIS data or your design data straight into those containers so that everything suddenly becomes intelligent and related to each other. The valves are related to the water pipes, for example. That sort of thing. That's a lot of work, but we give that to you out of the box. You can edit that, you can delete features, you can add your own features, and I'll show you that in a second. It also comes with an administration tool that allows you to create your own data models. Can't get that. Oh, there it is. You can see here is an example of a data model. These can be as complex as you want them to be or as simple as you want them to be. You can configure all of your features together. You can tell them how they react to each other. You can tell them what information they must have attached to them. You can tell them how much information they must have attached to them. And you can tell them how they get analyzed. Are they part of a network? All that sort of thing. You can also define reports against the data model, and you can define your own user interfaces. So if I log on, I might be only able to see the file open dialog in the interface. But if somebody else logs on, they may be given the edit tools as well. So for each user, you can actually change the look and feel of the interface. If you can imagine 200 people operating on this network, if we call it a network, that's a very powerful tool indeed. And I mentioned it, customizable forms and reports, the ability to select an object or many objects and see a wealth of information about those objects and actually print out reports. These are all based on SQL, and I don't know if anybody knows how to program in SQL. It's painful. But what Map 3D does is gives you an interface into that makes it easy. It's all drag and drop technology. So you can define reports like this without knowing how to program in SQL itself. Did anybody know that existed in Map 3D? No? Okay. Okay, let's have a quick look. How am I doing for time? Yeah. This is creating a simple data model using the standalone administrator. It's a desktop application. It's usually only operated by one or two people, the people who own the standards of the data model. It supports real-world coordinate systems, and it's a very easy to use drag and drop. What you get is what you see is what you get technology. So the first thing I'm doing here is creating a simple data model, putting in some feature classes. So these feature classes could be anything. Could be electric network, could be water pipe, anything that you like. It supports all the major geometry types, so you just say this is a water network, it's a line type object. In this case, I think it's a point type object. And Map 3D goes away and generates all of that code behind the scenes to create this schema. And you can see that by default, it's created geometry attributes, it's created an XY coordinate attribute because it's a point feature. If it was a line feature, it would have a length attribute by default, and it would automatically calculate the length of every line. Now what I'm doing here is just adding some attributes, so the information about the feature. And again, you know, there's many sort of data types you can have here. You can have booleans, numbers, text information, and so forth. And you just build up these feature classes. And you can have lookup tables as well. So if you want drop-down lists, so people have to pick a particular value, you can define these. And it's one of the ways where you know your information is going to be nearly correct, because they cannot actually select anything apart from these particular values. And then you just put in your actual values itself that you want. Now you can probably see, as simple as this looks, if you've got a big data model with a lot of different assets, this is going to take a long time. Which is why Autodesk created those empty buckets for the utility industry. Okay? So this is just hooking up a drop-down list of attributes with a particular feature class. Just want to move this on a little bit because I want to get to the report section. You see, here we go. This is, I'm hoping, oh, press that, there we go. This is a report or an attribute table where you can design the information that people see. So when someone selects a feature in a utility network, they will see this information. You can see here how easy it is to design these attribute forms. Drag and drop technology. You can hide things you don't want to see. You can add things you do want to see. You can add pictures, text. You can do complex calculations on your features as well. You can see the amount of capabilities you have up here. Just adding a picture, for example, here. But this is all very complex technology given a very simple user interface. It's powerful stuff, and hardly anyone knows it exists. Okay, let me move on. This is what a data model would look like in the Map 3D interface. So this is AutoCAD with some geospatial capabilities. This is actually a water network. And if I press play, it would be useful. And all of these features you see here are held in a data model. So the blue water networks here, some of the roads as well, they're all held in a data model. They have relationships to each other. They look like simple lines, but you can see here they're not. They've got a lot of information behind them. One of the most powerful things about the data model is you can automate different processes. So for example, if I'm creating a new pipe in my water network, these houses here don't have any running water. I'm not just drawing a line, I'm actually placing a real feature. And you can see I pick that corner, and then I pick the mains network. The data model created that line for me. It also created a snap with a junction on it, and then it shows me the attribute forms and says, please fill these in. And if you say so, if you don't fill particular bits of information in, the system will not create that asset. So some of these could be mandatory. So if you imagine that, what I just did was create a new asset that had, in simple terms, a color. It was blue. It knew that when it snapped to the existing network, it had to create a junction object. It then asked me to fill in some forms about that asset. And if I'd have said so, it would make me fill in certain bits of information. Now, if you can imagine a lot of people operating and designing in this way, the amount of time it will save in error assessment, and as-built errors and so forth. This is really powerful stuff. So if we take it beyond that, I've created my asset. Now if I can analyze that data. So say I just wanted to find out what is connected. I think this one creates another one. Let me move it on a little bit to save some time. Yep, I'm just going to create another one there. I'm going to move this on. So if I want to analyze this data, I can perform network analysis. So for example, if I have a pipe that's broken or a valve that's shut, I can ask the system to trace the whole network and show me the assets that are connected. So if you imagine that you might have an outage, you can inform your customers who will be affected by this outage just by performing a simple sort of trace like this. So you can see I've just traced the whole network. All of these assets know they're connected to one another. If I put some sort of condition in there, like broken pipe, I can retrace that and it will show me who will be affected along the whole network. So again, you know, the most important thing about this is the customer whose water is about to be shut off and they're not going to be able to have a shower. You can also see sophisticated reporting about this as well. So you can instantly produce paper reports, email shots, all that sort of thing to your customer base or to people who actually are interested in what's happening to your network. Really powerful technology, all geographically based, all based on sophisticated data models. Okay, so that is just on time, 45 minutes exactly. Very brief snapshot of the sort of technologies that we have at Autodesk for utilities.